Welcome to section 5.4. This is a general approach to factoring. This is Mr. West, and you're watching West Explains Best. Now, we're a little late with Valentine's Day theme, but I guess you can call February the month of love, so let's go ahead and get started. Love for polynomials. Now, this process, this four-step process will work with any polynomials in terms of factoring, okay? So the first step in factoring always is factor out the GCF. That is the greatest common factor. If you can do this, always do this first because it will make your life a little bit easier and make the problem a lot more simple to factor. So make sure you always do this step first. Now, step two, we're kind of breaking down the recognition part of the polynomial. So if the polynomial, let's say you factor out the GCF, or you don't factor out the GCF, it doesn't have one. If the polynomial has one of three conditions. One, if it's a binomial, check to see if it is difference of squares. Okay, so that's one possibility. Or some, whoops, that's not how you spell some difference of cubes. So most of the time when we're factoring, we're talking about trinomials, but difference of squares is when we have something like this, and then sum of cubes or difference of cubes is when we have some term that you can take the cube root of. Okay, so that's sum or difference of cubes. So if you have two terms, binomial, 1, 2, 1, 2, check to see if it's one of those two cases. If the polynomial is a trinomial, check to see if it is a perfect square trinomial. A perfect square trinomial. Okay, so trinomial, that's in the form of a squared plus 2 times the product of a and b, the square root of that first term, times the square root of that last term, which is b squared. Okay, so that is the general form for that. So if it's three terms, you're going to try to factor into that. And also you're going to try to factor like this if it's not. Two parentheses, two binomials, that's the general approach. If polynomial has more than three terms, try factor by grouping. Okay, factor by grouping can always be helpful when you have like four terms or more. So try factor by grouping, not grouping if those other two possibilities are not the case. If any of the factors can be factored further, do so. Okay, so for example, let's say you get done factoring. A classic example is when you have x to the fourth minus, 16? And you get x squared plus 4 and then x squared minus 4. When you think you're done, yes, this is difference of squares and I did this appropriately, but this can technically be factored further. So make sure you take this the next step and go x plus 2, x minus 2, and then your final answer will be this whole thing. So one of these factors could be factored further, so you need to do that. And then you check your answer at the end by multiplying or foiling, whatever you want to call it, distributing. You're going to be multiplying it all out just to see if it can get back to the original problem that you had. Okay, so we're going to do some examples. I'm going to go kind of quickly because this should be a review at this point. So here's our first example is 1000 m cubed plus 1. Okay, so it's two terms. It's a binomial, so I'm going to check to see if difference of squares or difference of cubes. Okay, this one is a cube, so I'm looking here, maybe 1000 is a perfect cube. It is. Maybe 1 is a perfect cube. It is. So I know this is going to be difference of cubes. How do I approach difference of cubes? Well, I have a formula for it. And I'm going to take this green, take this blue. Okay, I'm going to get my parentheses set up. And let's go ahead and get started. First thing I want to do is I want to take the cube root of this guy, 1000 m cubed. And I get 10 m, and that's it, 10m. All right, now I'm going to take the cube root of 1, and I get 1. Okay, now what do? Well, I'm going to put my blue here, here, and here. I'm going to put my green here, here, and here. So let me go ahead and fill those values in. For my green, I get 10m. I get 10m, I'll put that in parentheses squared, and then I'll put 10m here. I'm going to also put that in parentheses. Since it's plus here. This is sum of cubes. So I'm going to put plus in the first parenthesis. The last term is always plus, and then this one is minus. Okay, so as a reminder, this last one is always going to be plus. For sum of cubes, this first one is going to be plus, and this one's going to be minus. For difference, this is going to be minus, and this is going to be plus. Okay, and you can check out that video. It should be in the playlist if you want to check that out. Okay, lastly, we have my 1. This is the cube root of that second term. I'm going to put that there. 1, 1, and 1 squared. I don't need parentheses around it because it's only one term. Now I'm simplifying. So I have 10m plus 1. That stays the same. Can't combine like terms. 100m squared minus 10m times 1 is just 10m. Plus 1 squared is just 1. And there's my answer. So that's a quick recap of sum of cubes. Now here we have 2 parentheses. You can use factor by grouping because this is greater than 1, or you can just try different methods here. I like doing it this method where you have 2k and k, and then I just need to play around with the different possibilities. So I know this is minus, so my bigger one's got to be minus, so I'm guessing this is going to be minus, okay, because these two are going to get multiplied together, and their sum, okay, these 2 green lines are going to add up to this middle term. So because I know this 2k is going to be multiplied by something, I want it to be multiplied by something negative because I want the negative to win. Okay. So what is it going to be? Well, I'm going to put probably a 2 here and a 3 here, positive 3. This would give me a negative 4k, and this would give me positive 3k. Those two added together give me that. So this is my factored form right here. Trinomial, we're going to see if it's a perfect square trinomial. That was our second condition. This is not a perfect square trinomial because these are not squares, either in this example. Either in this example or this example, 3k x squared is not a perfect square. So we're just doing it the way we had before. Okay, so we have my parentheses here. I know my first term is going to go in factors are in this slot, and then my second term factors in these slots. I always start with my x, so I go 3k, or sorry, not 3k, 3x, oops, and this is going to be x. That will give me 3x squared. Now I need to think of my factors of negative 8. Okay, and I have a couple possibilities. It's a positive 10, so I know that these terms added together is going to give me a positive 10, but I need one of them to be negative. So I'm guessing it's a small negative. Let's make it negative 2 and 4. Okay, that works. I want my smaller one over here not to be multiplied by 3. My bigger one to be multiplied by 3. This will give me negative 2x. This will give me positive 12x. Those two added together give me 10x. This is the correct factored form. Let me use gold. Gold. Go for gold. Okay, now, more than 3 terms. Okay, this is 4 or more. So we're going to try factor by grouping. Okay, in order to factor by grouping, let's check out this. Well, we have these two both have a k squared. Okay, so that's good news. We're going to probably group those together, and then these two both have a factor of 9 or a negative 9. Okay, that's good news there. So let's go ahead and see if we can get something done and factor out the greatest common factor between those two groups. Here, the greatest common factor is going to be 4k squared. What does that leave me? It leaves me 5k plus 1. Okay, now let's go over here to the green. What's my biggest common factor is negative 9. That leaves me 5k plus negative 9 times what gives me negative 9? Positive 1. You should see here that I have a 5k plus 1 and a 5k plus 1. So what I can do now is I can factor out that 5k plus 1. And I'm going to leave in parentheses over here the result of that, which is 4k squared minus 9. This is what we did not use. And we're done. That is our factored form. Now, ooh, I almost fell for a trap. Remember, whenever you're done, you got to check this. If any of the factors can be factored further, do so. Well, what do you notice here? We notice that we have a perfect square in 4k squared and a perfect square in 9. That means it's the difference of squares. So I'm going to factor this further. 5k plus 1. This factors out to, well, we need to take the square root of both those terms first. Square root of 4k squared. gives me 2k. Square root of 9 gives me 3. Okay, so then what do I have? I need 2 parentheses for this yellow, like this. Okay, so this is my yellow. This factors out into the above. And I'm going to have, let me just keep it as purple. We're going to have 2k, put it in those spots. Then we have 3 and 3. Make one positive, make one negative, and we're done. This is the factored form now, completely factored. Last one, we have another factor by grouping. Now, this one's interesting because we have like 2 A's, we have a 1, we have a B. So one thing would be, okay, maybe we'd factor by grouping. We'd factor out a 4A here. We're left with we're left with A plus 1. And then we'd have difference of squares here. So we could go plus 1 plus B times 1 minus B. When you want to factor, you don't want a plus sign though. So we need to think of something else. So something else to try would be, okay, look, I notice this is a perfect square trinomial. Why? Because this is a perfect square and that is a perfect square. We're going to deal with this guy later. Okay? But this first one is a perfect square trinomial. So we're going to put it like this. Okay? Let me show you first. We put square root of this guy, square root of this guy, square root of this guy, square root of this guy. Okay? And then what we do is we just make it, apple pencil low, almost done, plus plus. Now this could be rewritten again as 2a plus 1 quantity squared. That's the whole point, minus b squared. Now, the whole reason that was okay is because if we got that into perfect squared trinomial, now we can do difference of squares. We have this guy, that's a perfect square, and this guy, that's a perfect square. So we can factor it into perfect squares. Difference of squares, sorry. So 2a plus 1 is the square root of 2a plus 1 squared. 2a plus 1 is the square root of 2a plus 1 squared. Square root of b squared is b. b, make one positive, make one negative, and that's it. That's our final answer. And there we go. So this is a general approach to factoring. Hope this is a good kind of selection of problems to help you understand how to factor any specific problem. Hope you enjoyed this video. Thanks for watching.